Okay. Okay. Colored pens up.
Who said what?
Colored pens up, and let's see how we did.
Awesome. That was awesome.
Number one, what did we get as function form? We got 1, 2, 3, 4, 5, 6, 7 confident people. We'll start Sharik, Brandon, and then Alyssa.
Y equals 2x minus half.
Okay. Okay.
Y equals negative 2x plus 1 half.
Okay. So the correct answer is y equals negative 2x plus 1 half. I was hoping you were going to notice that as you went along. Number two, what did you get? We'll start with Tristan, then Brian, and then Alicia.
Y equals 1. Y equals a half. Okay. Y equals half minus 3 over 4x.
Okay.
Y equals negative 3/4 x minus 1/2.
Okay, so that was slightly different.
Y equals negative 3/4 x minus 1/2.
Okay, so we get y equals negative 3/4 x minus 1/2. So, first of all, what Tristan said unfortunately turns out to be wrong anyway, but putting this, I'm sorry, we're working as a whole group now. Putting this first doesn't make you a horrible person, but I've emphasized with you a number of times over the past week that the x term goes first when you're writing down function form. So the x term goes before the constant. The x term goes before the constant. Okay? So, comments, questions on either of these? We'll start with Ania. Unfortunately, it is wrong. So if you put 2/4 instead of 1/2 anywhere, unfortunately that is incorrect. And I know that's a little bit harsh, but it's reality that you cannot leave numbers in unsimplified form. Okay, I do appreciate you asking. Next time, try to make sure you simplify everything. Any other comments or questions on either of these? Okay, well, let's back up for a second. Give me a thumbs up if you got both of them correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Put your thumbs down. So half the class. And nobody has any questions. So let me help you out a little bit. So here is the explanation for number 2 up here. I know it's a little bit small, but if you needed to, you could come up. Does anyone have any questions on either of them? Well, I'm going to do number 1 up here. So I'm not sure why it took me to prompt you more and more and more to then ask a question. And then I saw a few people actually react by looking at this and saying, oh my God, I can't believe that mistake I made. But why are you waiting for me to show you? Ask a question, get involved. So let's talk about question number 1. Give me a thumbs up if you got number 1 correct. Good. Alicia, what's the first thing you did?
I added 4x. Well, first I drew the
Good.
and then I added 4x.
Good. Eric, what's the first thing you did?
I subtracted negative 4x from both sides.
You subtracted negative 4x from both sides.
I hate myself.
Why? But you said you got it right, correct?
Yeah.
Okay. So in essence, what Eric was trying to say is he added 4x to both sides. You add 4x to both sides, this cancels. Here is the first major danger zone. This is a danger zone right here. You're going to see it happen again today. This stuff trips up my algebra students. But this is the difference between someone being moderately successful in my class You're being highly successful. When you cross out the negative 4x and the positive 4x, this does not disappear. This negative sign is attached to this. So that is a negative 2y. That must be brought down in its entirety. My students who are putting the number before the letter, it is at this point that you should now be writing this term first. 4x minus 1. So that's what you get after step number 1. What's the next step? Maria?
Divide negative 2 by each term.
I love the way you said that. Divide everything by negative 2, and this is how you were taught to do it. And so that is my expectation. This cancels out, and you get y equals. And now you get 4 divided by negative 2. It's negative 2x. And a negative 1 divided by a negative 2. Its top is negative, bottom is negative. That means positive 1/2. And that is the solution for this one. Comments or questions on number 1? Concerns? Okay. No other questions or comments? Okay, put the warm-up to the side. The title of today's new concept is Graphing Using Intercepts. This is the second method that you are going to be learning for graphing. The last time we were together, we learned the first method. That was called using a table of values. Using a table. Today is using intercepts. So, first, before we can get into graphing using intercepts, we have to have an understanding of what an intercept is. So to do that, I have a graph that I'm giving you, and I'm going to add some information to the graph, and that's where we're going to get our understanding of intercepts. So an intercept is the location on a graph where it crosses each axis. So we have the x-axis right here, and we have this graph, and it crosses right here at this location. This point is called the x-intercept. It's an intercept of the x-axis. The coordinates of this point are 2.5, 0. Those are the coordinates of that point. So we would say that the x-intercept for this graph is 2.5, 0. You will also often hear it said as the x-intercept is 2.5. So you can say that the x-intercept is just the x-coordinate. And I will often do that, is I will just say the x-intercept is 2.5. What I'm really saying is it's 2.5, 0. Okay? There's another intercept, and it's called the y-intercept. And it's the location where the graph crosses the y-axis, which is right here. The coordinates of that point are 0, 5. So we could say that the y-intercept is 0, 5, or we can say that the y-intercept is 5, meaning that it's crossing the y-axis at 5. So I don't really care which method or which way you say it, but this shows a deeper understanding of what's happening. So this is a more advanced way of writing an intercept. This is acceptable. This is deeper and more advanced. When I give you the answer sheets for the homework next time, most of it will be written in this form. The publisher took that route. That's fine. I can't control what the publisher did. Okay? Does anyone have any questions so far? So why are intercepts valuable? Why are they important? Well, I want you to look at this and this together, and I'd like you to try and see if there are any similarities between them. What similarities do you notice? 1, 2, 3, 4, 5, 6, 7 light bulbs. Alicia and then Jada?
Both of the coordinates are at 0.
Okay, what were you going to say?
Like the x coordinate is the x coordinate is labeled, but the y coordinate is like 0, and then the y coordinate is labeled.
Okay, so similar, you're focusing on the zeros. Any other observations? Ania and then Kamoy?
The y-intercept is double the x.
Okay, good observation. Very good. Kamoy?
They're both on the axis.
They're both on axis. Sharif?
They both are on the same line.
Okay, they're both on the same line. Very good, and that's, of course, very important. So, Ania, your observation was a really good one. It happens in this case to be a coincidence that this number is double this one. That won't always be the case. It just happened to be the case in this example. Okay, but that was a good observation. What I was really driving at is that they both have zeros in them. And Jada was really specific, and the 0 for the x-intercept is here, the 0 for the y-intercept is here, but they both have zeros. So what that means is it's actually very easy to calculate a y-intercept or an x-intercept. And since it's easy to find them, that means it's easy to draw a graph. Last time, when I taught the table of values, I asked you to have 4 points. 4 points to draw an accurate line. But in actuality, to draw a line, you need just a minimum of 2 points. That's all it takes. 1 point is not enough to draw a line. 2 points will draw a line. So if we can locate these 2 points for any equation, then we can draw the line and hence get the graph of that equation. So that's what we're going to be doing today. We're going to learn how to find these from an equation, and then we will draw a line through them. So let's put this into words. An x-intercept. An x-intercept is the x-coordinate of the point where the graph crosses the x-axis. Here's the important detail. To find it, you turn y into 0. And you're going to see how this is done in a couple of minutes. The y-intercept is the y-coordinate of the point where the graph crosses the y-axis. The key piece of information to pull away from this: to find the y-intercept, turn x into 0. Which makes perfect sense because look at the other coordinate for the x-intercept. The x-intercept is this number when this is 0. So if we turn that into a 0, then we will find that number. Last time we were together, I talked about how some of you are advanced enough to instinctively start to understand these processes and be able to just do them. But I don't want to just rely on whether or not your instincts will kick in. So what I do is I outline steps for you. So, graphing using intercepts. Step number 1, find the x-intercept. As I already said, to find it, we're going to turn y into 0. Step 2, find the y-intercept. To find that, we're going to make x into 0. Then, plot the points and draw a line through them. And then we will have a graph. Are there any questions so far? Often with this class, I will do the most advanced questions at the beginning of the lesson. Today will not be one of those cases. Today, we're actually going to learn how to find the intercepts first. We're not even going to draw a graph for another 10 minutes or so. We're going to just concentrate on finding intercepts. Once we have that skill down, then we're going to apply it to actually creating a graph. Are there any questions? If you're missing any of this, do not stress about it. I have a printed copy right here. You can borrow a little bit later. So we're going to jump right in and learn how to find intercepts. Find the x-intercept and the y-intercept of the graph of the equation. So I don't want you to graph it. I just want to know what the intercepts are. I'm going to label and organize my work because we need to find the intercepts one at a time. So we're going to do the x-intercept first. So here's what we do. To find the x-intercept, we make y 0. So we're going to take this equation, but we're going to replace the y with a 0. Negative 3x plus 4 times 0 equals 12. And so we're going to plug in a 0 right here. It's a trick. Not really a trick, it's a technique for finding the x-intercept. So this is now an equation for us to solve. But we need to make an observation. What do you notice about that expression right there? What's going to happen to that expression? Shelby? Say it just a little louder. Yeah, it's going to turn into a 0. Can someone say it a little bit differently? What's going to happen to that? What's going to happen to it, Sebastian? Well, what were you going to say? You were volunteering before. What were you going to say? Okay, that's what I was looking for. It's going to disappear. So this will disappear, which leaves us with this equation. Negative 3x equals 12. So solve this equation. What do we get for x? X equals what? Catalina? X equals negative 4. But this isn't really solving an equation the way we did in the first few chapters. What we did was we used a technique, to find a number that we wanted. It's really the x-coordinate of a point. So now we need to write out that the x-intercept, and you can either write, is negative 4 comma 0, or you can say it's negative 4. I don't care. I will understand, and I will mark both of them correct. But writing it as an ordered pair shows a deeper understanding of what we're studying. So this is preferred and more advanced, but the other is acceptable. Does anyone have any questions on this process for finding the x-intercept? Good, so now we're going to do the same thing with the y-intercept. Except, instead of replacing y with 0, we're now going to replace the x with a 0. And so now this is 0. What is going to happen to this expression? What's going to happen to that? Tristan? It's going to disappear. So as you get better and better at this, you will start to see that there's a pattern here. And these equations, when you're trying to find the intercepts, become really easy. So look at the equation we're left with. 4y equals 12. Everyone in this room can do y equals 3 mentally. You don't even need to do anything. But then you need to demonstrate that you understand what's happening here. That this means that the y-intercept is 0, 3, or 3. Does anyone have any questions on how we found the y-intercept? Okay, give me a thumbs up if you feel like you're a level 7 or above with understanding. Good, put your thumbs down. So let's see how you do on your own. Checkpoint number 1.
You said you ordered one of these, right? The drums? I didn't see your name on it, but I'm assuming it's yours. It's in the-
All right. So, x and y intercepts. I need volunteers for x intercepts. What did we get? We'll start with Alyssa and then Kayla.
-5, 0.
Okay, what'd you get? You got the same thing. The x-intercept is -5, 0, or you could have simply said -5. What about the y-intercept? What did we get? We'll start with Kezekiah and then Anissa.
0, -2.
Okay?
0, 2. I mean, -2.
It is 0, -2, or you could have said -2. Comments or questions on either of these? Comments or questions? Concerns? Okay, give me a thumbs up if you still feel like you're a 7 or above as far as understanding. Good, put your thumbs down. Now we're going to take this idea and apply it to constructing a graph. So, example 2. Graph the equation 3x minus 7.5 equals -2.5y. Now, if we wanted to, we could use the method, the table of values. If I wanted to, I could write this equation in function form, make a table of values, and then graph the equation. I would get an appropriate graph. But today we're learning a different method. We're learning how to use intercepts. So step 1 in this case is to find the x-intercept. So that's where we're going to start. To find the x-intercept, what do we do? To find the x-intercept, what do we do? Brian?
Oh, y equals 0.
Good. So we're going to rewrite the equation with y a 0. but you should be able to, being in this high-level class, be able to mentally already see that that's going to turn into a 0. Now, normally you don't write the 0 unless there's nothing else on that side of the equation. And then you do have to write the 0. Otherwise, you wouldn't know what to do. Now, it's a two-step equation, but it's a really easy one. Solve the equation. Add 7.5 to either side. 3x equals 7.5. You could do mental math with that. If you had $7.50 and had to split it between 3 people, how much would each person get? Sabari?
$2.50.
So the answer is 2.5. So we get x equals 2.5. But again, we want to make sure we're clear that that means the x-intercept is 2.5, comma 0. Does anyone have any questions on how we did that? Kezkai.
When did you say that when we use the zero and we do, when we use zero,
Well, I'm teaching you today a technique of finding the intercepts. So you're asking, when do I use a 0? Like, when do I plug in a 0 here?
like we were just talking about like see how it is on the equal sign where it goes.
Oh, okay, well, I plugged in a 0 here. What's negative 2.5 times 0?
Zero.
Okay, so if I don't write down the 0, that's what my equation will look like. Well, now what do? You get confused and you throw your hands up and say, I can't do that. But in actuality, there's a 0 there. It's right there. Why am I pointing this out? Because look what happened before. This disappeared. Did I write negative 3x plus 0? No, because you don't write plus 0 unless it's the only thing on that side of the equation. Okay? So here we had to write the 0 because it was the only thing there. Okay? Good. That was a good question. All right. Any other questions or comments on step 1? Good. Step 2. Now find the y-intercept. How do we find the y-intercept? Sheree?
To find the y-intercept, let x equal 0 and solve for y.
Very good. That was beautifully said. So now we've got 3 times 0 minus 7.5 equals negative 2.5y. But I already knew that this was going to disappear, but I wanted to emphasize something. That's why I wrote it down. This is a danger zone right here. Just like during the warm-up. If you were to cross this out or say that this disappears, a lot of times students take this negative sign and they think that disappears too. But it does not. So make sure that when you write this down, it's negative 7.5 equals negative 2.5y. If you forget the negative, you're going to get the totally wrong answer. Okay? So what does y come out to? What does y come out to? Aliana? Comes out to... All right, well, if I put a negative 3 here, negative times a negative will give me a positive number. Yes, it's positive 3. Very good. But you got to be careful about those positives and negatives. That's where most students get messed up. Which means that the y-intercept is at 0, 3. Yes, Maria.
Still get y to negative 7.5.
You don't get y, it's negative 7.5?
Oh, yeah.
Okay. All right, well, I'll also confirm with you individually when we're done with this question. Are there any other comments or questions? It's okay. I know sometimes I may talk in a way that makes you feel silly about something, but it's not really to dissuade you from asking questions. I want you to be confident. Yeah.
Okay, so if they're on the other side where it says negative 2.5 times y,
Yep.
like an equation, so if there was like a plus 3, then would you add 0 plus 3, or would you just put equals 3 for step 1 on that side?
If there was a plus 3 over here,
Would you add it? Like in step 1, would you add 0 plus 3, or would you just put 3? Or is it still the same?
we're only replacing the x with a 0. So if there was a plus 3 in the original equation, that can happen, but we're trying to find the y-intercept, which means we make the x into a 0 and then solve the equation. We're trying to get the x to disappear and solve for y. Is there an x over here? No. You're suggesting that if there was a 3. Okay? Am I answering your question? Okay, good. And you're going to see all sorts of different equations. Okay, so now we already knew how to do this. So now the next step is to draw a graph. So now we're going to plot the points and draw a line through them. The x-intercept, you need to draw a coordinate grid. You should go about 8 squares in each direction. That should be good enough. Depends on the situation. Some of your graphs are going to be much bigger than others. So now we're going to plot the point 2.5, comma 0. 1, 2, 2.5 is right there, comma 0. That is our x-intercept right there. And then our y-intercept is 0, comma 3. 0, 3. And now you use your straight edge and you're going to draw a line from one side all the way through to the other. Put arrows on either end to indicate that it goes on forever, and now we have an accurate representation of the equation. Does anyone have any questions on how we constructed this graph, where we got the points from, anything at all? Okay, one thing I want to remind you of is that what we just did was we represented all of the solutions to this equation in graphical format. So if I pick this point right here, and I get the coordinates, and I plug them in, that will give me a true statement. If I pick these coordinates right here into this equation, it will become a true statement. So any point on this line is a solution to this equation. That's the purpose of a graph. It represents all of the solutions. That's an important connection to understand. Does anyone have any questions about that? All right, let's see how you do on your own. Checkpoint number 2. You got 3.5 minutes. Of course, if you're confused or lost or feeling uncertain, raise your hand, and this is the time to get some individual guidance. There's a number of people still finishing up. Take another 30 seconds. All right, colored pens up. I'm not going to call on volunteers initially. First, I want to reveal the graph. And you need to see if you have the correct graph. It'll be easy to tell because you'll have the same x and y intercept that I have. So here is the graph. Now, I used a computer program to generate my graph, and my computer program was able to do it by ones and fit it in nicely. You might have had to go by twos. If you went by twos this way and this way, then your graph will look exactly like mine, just a little bit shrunken down. If you went by ones on the x-axis and then by twos on the y-axis, that's okay. It's not great, but you should still. Your graph will look a little bit different. Your graph will look, I think, more of a slope like this. But if you have the y-intercept and the x-intercept correct, then it should be fine. Kamoy, Brandon, Sharik.
I went by 5 on the y-axis and by 1 on the x-axis.
Okay. So the only problem with that is that it makes your graph look different, and then someone looking at your graph who is trying to get information from it might misunderstand. So again, we're doing a math class assignment. But if you now fast forward to when you are working with data as a scientist or in the financial world, drawing a graph and presenting it to somebody, it's a big difference if you have this graph versus that graph. There's a big difference. Like if you were trying to demonstrate growth, this shows more growth than this does. So it skews what you're looking at. You didn't do anything wrong, but if you can try and keep the same interval here and here on a graph like this, it will work better. Again, there's going to be times where we have to do things like that. Brandon, I'm going to get to you in a second. The second thing is that some of you are trying to conserve space on your paper. I don't know why. Make a bigger graph. I mean, if you're towards the bottom of your paper and you're like, oh, I want to squeeze it into this bottom corner, so I'll go by tens. instead of going by ones, well, just flip the paper over or go onto another paper and make a bigger graph. Some of your graphs will be small, some will be bigger. Okay? Brandon, and then there was somebody else. Go ahead. Oh, okay, you sure?
Yeah, I have 4 or 5.
Okay, that's fine. Were you next?
Yes.
Yeah, go ahead.
2 questions. One, so like as long as it's the same interval for the y-axis and the x-axis, the slope would be the same.
It should be the same, yeah.
And 2, you know how if they put like a different interval for the y and different interval for the x, is that like one of the techniques some advertisers use to get people into buying something?
Probably. There's a lot of different ways to make a graph look differently than it really should look. And you're right. Alyssa,
How did you get positive?
positive what? Okay, very good question. So your question is, how do we do this? So let's take a look. We want to find the x-intercept. To find the x-intercept, we set y equal to 0, right? So this is going to disappear. Yes?
Never mind. I forgot to put the negative by 36.
Okay, so that's a negative 36, so we get x is 9, and that's how we got that there. Okay? Okay. So you just, for both of them, you put positive 36. Okay, so that's just a writing error. That's not the worst thing in the world. Any comments or questions? Yes?
Well, I did wrong now because I thought it said 3.6 instead of 36.
Because I put this decimal here. Sorry about that. Okay. Now, how do we apply this to the real world? Now, example 3 is a real world scenario. I do not want you to copy the text of the question. I want you to write example 3 and I want you to read the question. This is a very realistic scenario. This is something that goes on all over the country, high school plays, professional plays, anything. They charge different prices depending on when you buy the tickets. If you buy the tickets, and it's very common, especially at the high school level, they want to try and incentivize buying your tickets early. They want to get as many people to buy tickets in advance, so they give you a little discount. So $4.50 for advance tickets, $5.50 if you wait to come to the door right when the show is going to start. The total sales were $452. How many tickets were sold of each? So the first thing we're going to do is just write an equation to represent the situation. We're already told that X is going to be the advance tickets, the number of tickets, and Y is going to be the number of tickets sold at the door. So starting from the beginning of the year, I've taught you to look for something first. What's the piece of information that I always ask you to find first? Oh, now we're starting to really get it. It's starting to click for you. Tristan? The total. Kamoy, is there a total in this question?
Yeah.
What is it?
402.
Yeah, it's pretty clear that 452 is the total. Now, what I started doing with you is we made a list of information down our paper. But now we're getting more and more advanced, and now we can jump right to constructing the equation. 452 is the total, and it almost always goes to the right. Now we just have to figure out what is going to add up to or subtract to the total. So now we need those other pieces of information. What was one other piece of information that I always ask you to find? David? You were going to tell us what the equation is supposed to be? Part of it? Okay, I'm going to come back to you, okay? So keep that thought. Caleb? The rate. Is there a rate in this question, Caleb? You think there's 2. What do you think they are? What do you think? Jada, you already thought you had part of it. Do you think she's right? There's 2 rates?
Yeah.
Yeah? I would agree with that. There are two rates because it's the cost per ticket, but it depends on how many tickets are sold. So we have two rates. So we'll get back to that in a second. What's that other piece of information that I always ask you to find as well? Anita? I will not wait.
Oh.
Yes.
Variable, right?
Well, we already have a variable. I was just kidding, by the way. Does Kai? A flat fee. So is there a flat fee in this question? Someone raise their hand and answer that. Is there a flat fee there? Brian? No, there's nothing that says, you know, oh, we had $1,000 in costs or something like that. So we have these two rates, and we're also given variables. So Jada, you said you had the first part. Go ahead, give it a shot.
The advance tickets is $4.50 times the amount of advance tickets.
Good. That was a phenomenal explanation. So how do I write it out in an equation?
I think it's going to be in colon algebra. It's 450 times x.
Good.
450x.
4.5, you could put the 0 if you want, 450x. And her explanation was great. This is the number of tickets, this is the price per ticket. Altogether, that's how much money we get from advance tickets. So now I'm just missing the tickets at the door. How do I represent that? Zabari? 5.50x?
Why?
It's 5.50y because we're told that x is the advance tickets, y is the tickets at the door. And so now we have an equation that represents the scenario. We at this point have no idea how many tickets of each were sold. All we know is that this represents the situation. Now we want to graph the equation. We could use any method we would like. Which method do you think we should use to graph this? You know two methods. Which method do you think we should use? Catalina?
I think we should.
Catalina, go ahead.
I think we should solve the equation using intercepts.
Yeah. Intercepts work really, really well anytime the equation is in this format. This is called standard form. You were already supposed to memorize it. And we're going to talk more about it later on in the year. But when an equation is in this form, finding intercepts is really easy. So we're going to go ahead and find the x-intercept and the y-intercept. So let's go ahead. X-intercept. How do I find the x-intercept? Anissa?
Replace y to 0.
Good. So you'll notice that that's going to make this disappear, and we're going to end up with 4.50x equals 452. Now you can use your calculator. So what do we get for x? What do we get for x? Got 1, 2, 3 people who got it already. 5, 6 people got it already. People sitting idly by, which means that they've got the answer already, and I'm going to call on them. Brandon, what does it come out to?
100.34.
It comes out, I think it comes out to 100.4 repeating.
Yeah.
Okay, so since this is a real world scenario and we have to graph this, what do you think we should call the x-intercept? What do you think it should be? What do you think it should be, Alyssa?
100.5.
Well, that wouldn't be too bad for graphing it. That's a good estimate. We'll make it even friendlier because we're going to have to fit that in here. We'll make it even easier. Tristan? Yeah, we'll just make it 100. Alyssa, yours is even more precise. Yours is an excellent, but when you're trying to graph something a number that large, doing halves is going to be a bit of a pain. So we're just going to say that the x-intercept is 100, 0, and that will be good enough for our graph. Does anyone have any questions on how we did that? So now we need the y-intercepts. How do we find the y-intercept, Kamoy?
We replace 450 with a 0, and then we do 5.50 y equals 450.
Okay, well, you said the second part right, but the way you said the first part was a little strange. You said replace the 4.50 with a 0?
It sounds better in my head.
Okay, good. I'm sure it did.
This,
I know what you meant.
yeah.
You meant replace the x with a 0, and that whole thing becomes a 0. And so we end up with the equation 5.50y equals 452. So go ahead and solve that equation. What do we get for that? I should see lots of calculator punching. And?
82.18.
Yeah, you get 82.18 repeating. And so what should we call the y-intercept? What do you think we should, how should we make it look nice? Kayla?
82.
Okay, so we'll say it's 0.82. So now we have the information we need to graph. And this time we do have to adjust the scale of the graph. So we'll go by tens. That'll make it work nicely. So we need to do 100, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And then we need 0.82. That's 10, 20, 30, 40, 50, 60, 70, 80. 82 is going to be a little bit above that. And now we're going to use our straight edge to draw a line through it. Yes?
I don't think you should go past to the negative because you can't sell negative.
Interesting. Not only is he correct, he also read my mind, which kind of frightens me a little bit. Because I was about to ask if anyone had an issue with my graph. And he's the first person out of all my classes to be able to pick out that detail. And this is the kind of detail that you have to really pay attention to. So I apologize for making you graph something and then we're going to have to erase a little bit. But yeah, if you drew this graph, I would mark it wrong. Because his explanation was spot on. What was the end part of your explanation?
Can't sell negative.
Yeah, and what this means, every point on this line, I want you to pay attention to this. Every point on this line represents an ordered pair of a number of tickets sold in advance and a number of tickets sold at the door. So for example, this point right here, that's 10, 20, 30, 40 tickets sold in advance, 10, 20, 30, 40, 50 tickets sold at the door. So that's one way to make $452. But look at this point right here. That represents negative 10, positive 90. Is it possible to sell negative 10 tickets in advance? No, it doesn't make any sense. So Brian's explanation is fantastic and very, very important. We cannot draw a line through it. In fact, this line will actually not have arrows on either end. It must start here and end here, and that's it. And now what we have is a tool to make predictions. In other words, I started out the scenario by saying we made $452, but what if I said our goal was to make $452? If I said it like that, then what I have is a prediction tool, and I can say, well, if, you guys got to pay attention, if I sell 20 tickets in advance, how many tickets do I have to sell at the door to meet my goal? Well, then I would jump up to the graph over here, and then I can see that I would have to sell that many tickets, 10, 20, 30, 40, 50, 60, about 67 or 68 tickets at the door. to meet my goal. So this is now a prediction tool to help me decide how my event is going to go. And that actually leads us to question C, which says, if you sold 54 advance tickets, how many were sold at the door? So now look at your graph. If we sell 54 advance tickets, how many tickets were sold at the door? What do you think? There's no calculating involved. You just look at your graph. What do you think? Shelby? What's that? You weren't ready yet? Oh, what I'm saying is if we sell 54 advance tickets, meaning along here, how many tickets would we have sold going this way? So I'm saying look at the graph. Sebastian and then Ania. How many do you think?
Approximately 38.
Okay, what were you going to say? I'm sorry? Approximately 40. Kayla? 35. Kamoy?
Around 50.
Around 50. All right, so let's take a look. 54 would be 10, 20, 30, 40, 50. 54 is a little less than halfway. Now I go up to my graph. It's about right there. Now take my graph over to here, and I hit about right there. So that's 10, 20, 30. I'd say 37, 38 is a pretty good estimate. 40 is not terrible, but it's a little bit off. Okay? So it's now a tool that you can use to find all different combinations. Does anyone have any questions on how we did that? Kamoy?
You're asking us to guess the Y.
Well, which axis is the advance tickets? So the x-axis is advance tickets, so I already told you that it was 54 going this way. So I was asking you what would it be going that way. Okay, draw a line across your paper, your classwork. You're going to start on page 37, and you're going to do number 26, and you're going to work your way backwards. You're going to do 18, 17, 16, and 8. It's 5 questions, but each question takes a little bit longer. Okay. Colored pens up. All right, here is 26. The x-intercept was 20,358. The y-intercept was 15,834. And your graph should have looked like this. For part B, you could have had a whole bunch of different answers as long as you gave an ordered pair that was somewhere on this line. As long as your ordered pairs were somewhere on this line, you can mark part B correct. Numbers 18 and 17. Here's 18 and 17. Let me move this up a little bit more. Here's 18 and 17. And the last two questions. Number 16 and number 8. All you were asked to do is find the x-intercept and y-intercept. All right. So unfortunately, due to time constraints, I'm not going to take any time to answer any questions, and I apologize for that, but my care class is open for you every morning. So if you have any questions or concerns, you come to my care class. So, everyone draw a line across your paper. Your homework is page 233. You're going to do numbers 20 through 46 even. Now, I have an issue that comes up with all of my classes where as the assignment goes on, students start skipping the questions at the end. And I put a little note here, and I put it here, but I shouldn't even have to tell you. When I give you an assignment, all of the questions are required. But the most important ones are the ones at the end. They're not the least important. You're basically building up to those important questions. I would rather, if you had to, I would rather you do 42, 44, and 46 and skip the rest of the assignment than the other way around. Now, of course, you should do everything, but those are the most important questions. Also, you have a quiz on Wednesday. The quiz on Wednesday will be 4.1 to 4.3.